Welcome from the studios of KPBS TV at San Diego State University. The International Training Center today brings us all together in this teleconference. We welcome Mexico, the Dominican Republic, Costa Rica, Panama, Colombia, Venezuela, Peru, Paraguay, Brazil, Argentina, and the United States of America. We would like to thank Keystone Communications, Telecomunicaciones de Mexico, PanAmSat, and BrazilSat for their satellite linkage services which make this all possible today. Welcome to our program on the Multinational Virtual Organization, Guidelines for Adopting Information Technologies. This is the third teleconference of the series Principles for World-Class Performance. Today's program is composed of 2 presentation modules and 2 question and answer sessions. We look forward to your live participation. I am Dr. Michael Reel, Director of the School of Communication here at San Diego State University, and your moderator for this teleconference. The proliferation of new information technologies presents a challenge to business, education, and government. With transborder technologies like the Internet and the World Wide Web, it is now possible for even medium-sized organizations and smaller ones to operate as multinational units, connecting with and serving clients in other countries and regions. Today, we are eager to explore with you the technologies and problems of competing in the new information age. What are the basic considerations and guidelines for adopting different services and equipment? How can maximum international connectivity be achieved at minimum cost? What are the advantages and disadvantages of the Internet, the World Wide Web, email, intranets, ISDN, HDTV, DVD, Java, and the other acronym-labeled opportunities available? What specific applications should be implemented to compete successfully as a private business, an educational leader, or a public agency? Our guests today are Dr. Farhad Saba and J. Michael Mahone. Dr. Saba, as many of you know from our previous video conferences, is a distinguished faculty member of the Educational Technology Department at San Diego State University. With 20 years of experience in telecommunications-based education, he has been involved in all aspects of the field, ranging from policy analysis and design to implementation and evaluation. Dr. Saba is a former director of educational radio and television in Iran and former telecommunication division director for the University of Connecticut. He holds a bachelor's degree in radio, television, and film, a master's degree in broadcast communication arts from San Francisco State University, and a PhD in instructional technology from Syracuse University. Our next guest, Mr. J. Michael Mahone, is owner and president of J.M. Mahone Company. He has developed numerous Internet and information systems management plans. He has provided services to many large and small companies in California and other states of the Union. He has published many articles on the productive use of new technologies based on the Internet and the web. Mr. Mahone holds an MBA from the University of California, Irvine, with emphasis in information technology, and an MA in psychology from Humboldt State University. Welcome. Let us begin with an introductory question. Briefly, what is the most common failing you encounter as an organization attempts to utilize a new set of technologies? What is the most common mistake?
Number one is, what I've experienced is not having a plan that defines who is going to accomplish what task and what the outcome is going to be.
Dr. Saba?
Absolutely. Having a well-developed and well-detailed plan is of absolute necessity. However, that plan should not be impeding the process in the future of the implementation of the project.
Thank you. We will continue. Thanks for your comments. Now we will begin with Module 1, in which Dr. Saba will identify some of the technologies of opportunity and influence in our new information age.
In the past 6 years, networked computing, cable, and satellite television have made the virtual office possible. Global communication has made it possible for managers, supervisors, engineers, designers, and frontline workers to use telecomputing and video conferencing around the globe to share and exchange information as if they were under the same roof. Today, desktop video conferencing, room video conferencing, as well as a host of other computer-based capabilities, such as screen sharing and application sharing, have made working with another person across the globe as easy as working with the same person across a table. For example, Don Tapscott, in his book, The Digital Economy, presented several examples for products created in global virtual offices. The Boeing 777, according to Tapscott, is the first aircraft that was designed and developed without physical blueprints and models. What's more, engineers and project managers in many locations across the globe collaborated in designing the different parts of the aircraft. Employees of other major multinationals, ranging from General Motors Corporation to retailers such as Walmart, work in electronic virtual spaces to reduce the cost of design and production and increase the productivity of their organizations. The International Herald Tribune, in its January 4, 1997 issue, reported that as of the third quarter of 1996, American-based businesses and industries spent $251 billion on information technologies. The article went on to list how companies such as Chrysler Corporation and Dell Computers have increased their productivity by innovative uses of information technologies. Such innovations have included anticipating surges in consumer demand and squeezing more production into existing factories, sharing parts of similar products so that new units can be manufactured with less parts, monitoring sales at the checkout counters, and restocking inventory based on real demand. These and other management techniques, such as team building and collaborative problem solving, have made it possible for companies such as Walmart, the largest retailer based in the United States, to streamline the operations of its 2,268 stores towards real time. As you can imagine, it is impossible to streamline the operations of more than 2,000 stores across several time zones and in many different locations without a heavy reliance on computers and telecommunications services. But how do we design such information systems? Are similar services and technologies available in different countries? Do they match in standards? Can they talk to each other? Are they reliable? We're going to respond to these questions in the remainder of this segment of our program. We can set the tone of this segment by quoting Bill Gates, the chairman and the chief executive officer of Microsoft, the largest producer of computer software in the world, who said, "Today, everything is in a state of flux, even the status quo." We live in a world of constant change, one in which predicting and controlling the future is becoming more and more difficult. Today, more than ever before, we have to contend with this contradiction. The only constant is change. And this contradiction impacts the work and life of information technology managers more than anyone else. Information technology is the fastest changing sector of the economy today. This means that not only current computer and telecommunication technologies are bound to change rapidly, but new and novel technologies are going to emerge in the future. The last few years of this century and certainly the next millennium will be characterized not only by rapid improvement of current technologies, but an accelerated rate in the growth of our knowledge base, leading to the introduction of unprecedented technologies. In fact, economists such as O'Driscoll and Rizzo, in their recent book, The Economy of Time and Ignorance, have asserted that post-industrial economies are approaching real-time speed in the rate of development, and have begun to lay the ground rules for modeling such economies based on dynamic systems. I am emphasizing this phenomenon of rapid change to convey to you that in the future, we as information technologists have to be ever more vigilant in learning about new technologies and updating our standards to meet the demand of those who rely on our judgment and services. This rapid change seems to be inevitable, and it will impact the life of the information technologist more than the life of any other group of professionals. One example of this rapid change is the decentralization of telephone systems in Mexico. To be sure, decentralization will make phone services more flexible and more responsive to the local needs of customers. However, change always comes at a cost. As new phone systems and services in your area becomes available, you need to keep abreast of such new developments to learn how much these services will cost you, if you can have access to them both at your site and site of the receiver, how widespread these services are, can all your clients access them, and last but not least, how usable they are. Do they really solve a problem for your organization? Having said this, let me continue by presenting some of the current and emerging standards in information technology. To be sure, these standards are bound to change in the future, but I hope a knowledge of their current status will help you to cope with their rapid change in the future easier and better. Let's begin with ISDN, which has emerged as the standard for fast data transmission and video conferencing. ISDN, which stands for Integrated Services Digital Networks, makes your ordinary copper wire twisted pair phone line a fast speed line. It changes your analog phone line to a digital line, therefore making it possible to run more information through it. Each ISDN line can carry as much as 64 kilobits per second. By combining lines or bonding, you can achieve faster speeds and more flexibility in bandwidth for high-end telecomputing, which may include high-resolution graphics or real-time two-way video conferencing. ISDN is an international standard adopted by almost all telephone companies worldwide. Different countries, however, are at different stages of implementing ISDN. Most Central and South American countries are deploying ISDN services at the present time. Major carrier telephone companies have been expanding their cross-border fiber optic telephone trunk lines called E1 and T1 lines, depending on their capacity for data, voice, and video transmission, as the market for business and educational applications grows internationally. Sapien and Piedmo, in their recent book, Mastering ISDN, reported that Brazil, Chile, Colombia, Curacao, and Mexico are at the leading edge of applying digital communications. If you live and work in any of the Central and South American regions, you can have high-speed digital telecommunication from your desktop or room video conferencing system within your country throughout the Americas, as well as to Europe, Asia, Australia, and many African countries. ISDN telecommunication services, however, are not similarly provisioned throughout the world. Although all phone companies basically use the same standard, each may differ in their particular flavor of ISDN. Therefore, if you are thinking of purchasing ISDN services for your company, You need to learn about how your local phone company has provisioned ISDN services, if they can provide you with long-distance and international services, if you need to change switching equipment at your location, if you need to equip your computers with ISDN cards, and if you need to change old terminal equipment, such as your analog telephone sets, to new digital ones. Perhaps the most important advantage of ISDN is, however, that it uses your current phone lines, and you need not to run a new network of wires to use it. In addition, ISDN will allow you to use desktop and video conferencing as simply and reliably as you use your ordinary telephone today. Have much faster access to the Internet, which is a great advantage if you use the World Wide Web. Transfer graphic data such as blueprints, sketches, and 3D models, as well as audio and video files at a much faster and more efficient rate, and share computer files in real time across the street or around the world to collaborate with your team members and others. So, if you are interested in spending less time waiting for files to download or upload, navigate through the web faster, and collaborate with your colleagues in real time via audio and video, you need to seriously consider ISDN. It is an international standard which works today. Since ISDN uses already installed copper wires, its cost to the customer is not very much. For example, in the United States, ISDN services are available for $25 per month plus usage, which averages $15 per minute. With a terminal adapter at the price range of $400 to $700, one can access ISDN services for data communication and video conferencing. Another important emerging standard is HDTV, or high-definition television. The story of HDTV goes back to the 1980s, when Japanese government agencies, including the NHK, decided to develop and broadcast a high-resolution television standard. The new standard was going to provide very high-quality video and audio to viewers. For years, since the advent of broadcast television in the 1940s, three standards dominated the industry worldwide. NTSC, which stands for National Television Standards Committee, developed in the United States. This standard is still in use. In fact, the picture you're watching now is generated by NTSC equipment in this television studio. PAL, the German standard for television equipment and transmission, and CCAM, which was developed in France, were the other two standards which were accepted by many countries throughout the world. Today, around the globe, television broadcasters use NTSC, PAL, and CCAM to generate and transmit television pictures. These systems generate the type of resolution and picture quality which you are watching now. NTSC, for example, has an aspect ratio of 4:3 and a resolution of 525 lines per frame. CCAM and PAL both have a higher resolution than NTSC, but the same aspect ratio. None of these standards can even come close to the resolution expected from HDTV. Digital technology has made it possible to produce and transmit television pictures and sounds as good as motion pictures, in the same aspect ratio and sizes which we are used to seeing in movie theaters. NHK, as I mentioned, took the lead in producing the first HDTV system. This, however, did not become an accepted industry standard. Very quickly, European countries began to set their own standard. The U.S. lagged behind Japan and Europe for several years. It is only within the last 2 years that the Federal Communications Commission, or FCC, the regulatory body of the United States government in charge of telecommunications and broadcasting, has been moving the standardization process of HDTV forward. To arrive at a new television standard, any regulatory body has to overcome several problems. First and foremost, it has to make sure that the new standard does not deprive current owners of NTSC, PAL, and CCAM equipment of watching their favorite programs as broadcasters switch to a new standard. The second problem, or really the opportunity, is that with digital television, it becomes possible to send and receive video signals by computers through computer networks as well as through broadcast networks. And therein lies the current status of HDTV, at least in the United States. The FCC is currently considering technologies which could accommodate both the broadcast television industry as well as the computer industry. With sophisticated chips installed in TV sets, the FCC may not even have to set a single standard. The commissioners may decide to let different digital encoding, compression, and transmission technologies compete in the marketplace without having to make tough decisions in selecting one technology over all the others. Also, on the international level, Japan as well as European broadcasters have not been idle. They are also busy working on their own new standard, since whoever comes with the most acceptable technology in the marketplace can seize a multi-billion-dollar manufacturing and marketing opportunity for many years to come. We will keep you posted in future programs as this story continues. Whatever the new standard may be, HDTV will offer far superior picture quality than current NTSC, PAL, and CCAM standards, the possibility of true interactive television by which the viewer can not only receive information but also send information, and the capability of adding a plethora of supportive information services to the video and audio signal. You can imagine the possibilities, especially for training and education. In addition to video and audio, you can send and receive text, graphics, print documents, etc., not to mention two-way video conferencing and collaborative multi-point virtual network environments, all through a technology that does not have the current bandwidth limitations of the Internet. We all need to keep abreast of HDTV developments in the future, not only as professionals who have to make decisions regarding such technologies for our organizations, but also as citizens who would be interested in the future of television services available to us at home. The future of HDTV, regardless of the standard, will be an exciting one for professionals in information technologies, training, and development. And I hope our explanation here has helped you to understand the nature and complexities involved in this standard better. HDTV requires twice as much bandwidth as regular television broadcasts. The signal we are generating in this broadcast needs 6 megahertz of bandwidth to reach you. Uncompressed HDTV, on the other hand, needs 12 megahertz. Given the limitation of over-the-air broadcasts and coaxial cable, HDTV services will eventually require fiber optic lines or a new range of over-the-air frequencies, the so-called wireless communication. Fiber optic technology can carry virtually unlimited bandwidth and is already a major player not only in domestic communication systems but for transnational and transcontinental communication as well. Wireless technology, however, is relatively new, and its standards will be subject to change as it evolves in the future. A case in point is the rapid obsolescence of cellular phones as the digital personal data communication systems are becoming available in more markets. For more information on HDTV, I suggest you read an excellent article by Charles Platt in the February 1997 issue of Wired magazine. The article is also available on the World Wide Web at the address that you see on your screen. If you're a music buff like I am, then chances are that you have been buying your new additions to your collection on a compact disc like this that I'm holding in my hands. Since the 1980s, the music industry gradually faded out the vinyl records as the medium of distribution and replaced it with the compact disc. Today, almost all musical recordings are sold on compact discs worldwide, truly a universal standard. The computer industry followed suit and adopted the compact disc as the medium of choice for distribution of large volume reference materials, as well as games and multimedia programs which needed much more storage space than the floppy disk. The compact disc with 650 megabytes of recording room could handle video and audio as well as text and graphics, which is standard fare for multimedia training and presentation programs, as well as for reference materials such as encyclopedias and games. The speed of reproduction for audio and video on a CD, although not ideal, was reasonable for most educational and training needs compared to its predecessor, the analog video disc CDs, although were based on the superior digital technology, did not satisfy the needs of the entertainment industry. The CD just did not have the storage capacity to record full-featured movies, along with supplemental materials as promised earlier. Moreover, disc players were, especially in late 1980s and early 1990s, were too slow to reproduce movies at a reasonable speed which would satisfy the average movie fan. The industry was in search of a new standard that would have sufficient storage space and speed to accommodate full-feature movies as well as their original script, trailers, posters, magazine and newspaper review interviews with filmmakers and actors, and even footage showing how the movie was made. It seems that a new standard is emerging in the form of digital video disc. Although not in your corner video store yet, this is a technology with which you should become familiar if you're an information technology professional or in the training and education or interested in new distribution media for entertainment programs. The single-layer DVDs, which are marketed as we speak, has a storage capacity of 4.7 gigabits. This is 7 times more than the capacity of CDs currently in use. For example, a DVD can hold up to 133 minutes of high-quality audio and video in MPEG-2 format. The first series are read-only or DVD-ROM and can be used either by computers as a replacement to CDs or by special drives for entertainment purposes. Several manufacturers are currently marketing DVD-ROMs, including Toshiba, Philips, Sony, Hitachi, and RCA. RCA, for example, boasts a collection of 4,000 movies on DVD-ROM. The second series are dual-layer discs and have twice the capacity, or 8.5 gigabits. They are likely to be released in the second half of 1997. In the more distant future, it is planned to use double-sided, double-layered discs, which increase their capacity to 17 gigabits. The DVD-ROM drives will read existing CD-ROMs and music CDs and will be compatible with installed sound and video boards in computers. Subsequently, the DVD-ROM family will be expanded with a one-time recordable version referred to as DVD-R, and finally a rewritable version referred to as DVD-RAM. Write-once DVD-R drives will record on a 3.9 gigabits disc. To keep current on this technology, we suggest that you read popular magazines such as the Video Magazine, New Media, or DV. Also, you can consult web pages of TMG Tactical Marketing Group at the address on your screen. I would like to credit TMG as a source of information presented in this program on DVD technology. Another emerging standard that is bound to provide more power and functionality to your computer network is the Java programming language. Java and JavaScript appeared on the scene simultaneously. However, they are fundamentally different in their application and use. Both will have an essential role in increasing the functionality of computer networks on a global scale. The major difference between Java and JavaScript is that Java enables you to develop application software, whereas JavaScript only can increase the interactivity of your web pages, but is not suitable for writing applications. JavaScript is an authoring tool, much like Macromedia Director's lingo. It works hand in hand with your HTML codes to make web pages more informative, interesting, and interactive. You can embed JavaScript codes as you create new web pages using HTML. There are many examples of JavaScript on the web. For more information on how to use JavaScript, visit the location on your screen. Java, on the other hand, allows you to write application programs. Java applications are called applets, and they are platform independent, meaning they run on any computer which happens to be on a network. Applets are bound to increase the functionality of computer networks dramatically. Let me give you an example. Online banking is becoming more and more a reality as customers can access their accounts from a desktop computer at home, transfer money, pay bills, and set aside funds for a future vacation, among other anticipated expenses. To do so, the customer may need an accounting program to run some if-then scenarios to help him with decision-making. What if I set aside 3% of my monthly income for a future vacation? What if I set aside 5%, etc.? Such an accounting program, as well as more sophisticated and powerful ones, can reside on a bank's computers in the form of a Java applet. The customer automatically downloads the applet as a connection is made to the bank's network. The applet will work on any computer that the customer may have. It resides on the customer's machine as long as the customer is using it. It will be erased from the customer's machine once he or she closes the applets. Thus, businesses and industries of various sizes and kinds can develop very useful applications that are tailor-made to the specific needs of their employees or customers without concerning themselves about the availability of application programs on the user's machine. As you can imagine, the ramifications of Java applets for companies that do business on a global scale is enormous. Using Java applets with little or no concern for the computer operating systems at the user's end, companies can increase the functionality of their computer networks tremendously. If you have not addressed the use of Java for your information system, I encourage you to do so. Java was created by Sun Microsystems